Hello and welcome back to Teach Me in 10. In this episode, we're talking to Thomas Smith, EMEA Applications Laboratory Team Leader at Biotage. Thomas will present an advanced sample preparation workflow for analytical chemistry, and will explore how it can be used for a large drugs of abuse panel and THC analysis from human fingernails. He will also share some tips and tricks to enhance both recovery and reproducibility of your sample preparation methods.
Hello, thank you for the introduction. Yes, I'm Thomas Smith and I'm the EMEA Applications Laboratory Team Leader here at Biotage. So today I'm going to run through a couple of application notes that were developed in-house by our R&D team here in Cardiff. They use the full Biotage analytical workflow solution. Both application notes are using fingernails as the matrix, one of them extracting a large panel of DoA and the other a THC panel. As well as I've got a few tips and tricks to use when analysing for DoA and THC. So firstly, why would we use nails? So the common biological matrices for drug detection are sort of oral fluid, urine, any blood-based matrix. However, some of the issues here could be time frames, so they only really assess a few days up to maybe a few weeks. They require specific storage conditions such as temperature control, so freezing, refrigeration, the addition of surfactants to prevent degradation, and also some anticoagulants. Their collection techniques tend to be invasive, and for long-term monitoring, you do need repeat collections at specific time points. On the other hand, nails grow at an average rate of about approximately 3 millimeters per month. So therefore, you can get a longer time frame of drug intake or exposure. They're a keratinized tissue. This means then they are a lot more stable, so they do not require any specific storage conditions for transport. However, they are a solid matrix, so the pre-treatment you do require some grinding, pulverization, some homogenization there, and you can have some external contamination, such as sweat, nail polishes, gels, so an efficient decontamination step is required prior to extraction. As we're dealing with the solid matrix, we use the Biotage Lysera for pulverization. The Lysera is a bead mill homogenizer. It's used to automate grinding, lysing, homogenization of solid samples. There's an interchangeable finger plate, which allows processing of small and large sample volumes and weights. For the nails, we used approximately 10 milligrams of nails, so a 2 milliliter tube was perfect, which allowed us to simultaneously pulverize 24 samples. We also have the opportunity to store up to 99 programs, so reproducible runs are just simple at a click of a button. The Lysera settings are customizable, so we can change the speed of the pulverization. So for this we did 6.95 meters per second. We did it 8 times for 45 seconds with a 45-second dwell in between. The system allows for both dry and wet milling. In the case of nails, it's better to dry grind to a fine powder and then dilute for the drugs of abuse with a 0.1% ammonium hydroxide, and with the THC, a 0.1% formic acid solution. This was mixed and finally centrifuged. We cleaned up using Isolute SLE+, and this was automated on a Biotage extraherer. So SLE is analogous to liquid-liquid, in which the extraction is based upon the partitioning of the DoA and the THC panels from an aqueous sample into a water-immiscible elution solvent. The extraction efficiency is dependent on the solubility of the analytes in the elution solvent. So the aqueous sample is loaded onto the bed and left and wait for 5 minutes. The sample is dispersed into small droplets on the bed, and then a water-immiscible solvent is passed over this, allowing the analytes to partition from the bed into the elution solvent. For the drugs of abuse, it was a direct load of the previous step. So this was 400 microliters. For the THC, the previous step was evaporated at 40 degrees and reconstituted in a 250 microliters of 80-20 methanol water solution. Then after the weight, for the drugs of abuse, we eluted with a DCM IPA solution followed by an MTBE. The THC was eluted with 2 times MTBE. So the extraction, as I said, was automated on the Biotage extrahera, which is our automated sample preparation system. Doing this just allowed us to improve the throughput of the method, and we will go through the results now. So we covered a large panel, which included amphetamines, cocaines, opiates, benzodiazepines, for example. These are varied in their characteristics as well as their functionality. So it's a range of polarities as well as different strength bases. And the graph here shows that the recoveries were greater than 80-90% for the majority of the analytes, with RSDs less than 10% and very minimal ion suppression. For the THC panel, results were similar. So we looked at THC plus some metabolites, the hydroxy and the carboxylic acid, as well as cannabidiol and cannabinol. And here, the recoveries again were 80-100% for the majority of the analytes. RSDs were less than 10%, and again, minimal ion suppression was seen. So we evaporated after the SLE with a TurboVap 96 Joule. So this is a where it was designed for a 9648 or 24 well plate evaporation, as it's got an interchangeable nozzle head. It's heated nitrogen from above blown onto the sample with a plate heater underneath for an efficient evaporation. You can also save up to 10 methods here. That allows reproducible runs from any analyst in the lab at any time. Both the DoA and the THC panel were evaporated to dryness and then reconstituted with the details explained in the application notes. So the evaporation can often be overlooked during method development. It's a very important step, so it is vital to ensure that this step is suitable before proceeding with any sort of further development. It is very easy to lose your analytes of interest at this stage, so I'd always recommend to do this early method development. And I've got a few examples of where sort of the losses of your analytes can occur. So for the drugs of abuse, a very important step is an addition of an acidic methanol solution into your elution solvent. This is perfect, or this works well for the volatile analytes. So by decreasing the pH, you are decreasing the volatility of the analytes. The green here shows there's no hydrochloric acid solution added, with the purple 100 microliters of a 50 millimolar hydrochloric acid and methanol solution. As you can see towards the front here, examples are amphetamine, AME, methamphetamine. We are seeing a lot of losses, or up to 50% losses without the hydrochloric acid. So this is a vital stage for any drugs of abuse evaporation step. The solubility of your analytes is very important. So here's the THC panel. You can see here, as you increase the percentage organic, which is in the mobile phase B, so this is 90-10 mobile phase A all the way down to 50-50, you are improving your recoveries, especially for the more non-polar analytes. So at 90-10, they are recoveries around about 10%, whereas once you get to 50-50, they're up near 100%. This is going to improve the sensitivity around analysis as well. The collection vessel is very important. So depending on your analyte's capability for non-specific binding, here is an example between glass and plate using a 50-50 mobile phase A, B, so a 50-50 aqueous organic reconstitution solvent. So from switching from glass to plastic, you are affecting the recoveries by up to 50% again. This can also depend on the plastic's makeup or the cleanliness. But if you are using 96 well plates for evaporation, you must take a look at this step. So we did a couple of investigations in the lab to see if we can improve this. This graph here shows us firstly adding 100 microliters of pure methanol and vortex in whale, and then diluting further with an aqueous solution ready for injection, just to avoid a solvent mismatch. And as you can see, the improvement here goes from approximately 40% up to around about 55-60%. So you are seeing about a 10 to 15% increase for your non-polar analytes. And then we looked at the solubility, so the possibility of using different organic solvents. And here we tested IPA first. And again, we're seeing a 10%, 15% increase when using IPA. So this was 100 microliters of IPA into your sample, vortex for a few minutes, and then dilute with aqueous, ready for injection. This method wasn't undertaken during the development of the application notes, but we know it for future development work. But we were still able to obtain LOQs, good LOQs, without using this step. So in summary, nails are a great matrix to use, I'd say, as a complement to traditional biological matrices, and can help give an overview over a long period of potentially abstinence or chronic exposure. We've developed 2 application notes which are available at our website, so at note 916 and 929. It's an automatable method, so it can improve your laboratory efficiency, and we've also addressed some evaporation considerations to think about during method development to maximize your sensitivity. I'd just like to say thank you to Lee Williams and the R&D team for the development of this app note, as well as Monica Veget and Venius Skoukalkas, who supported me during the evaporation considerations. Thank you. I've been Thomas Smith, and if you have any further questions, please don't hesitate to reach out.
Thank you for joining us for another episode of Teach Me in 10, which was brought to you by Biotage. Biotage is a global supplier and solutions partner to a wide range of customers within drug discovery and development and analytical testing. Thomas introduced the Biotage iSolute SLE Plus products, which efficiently extract analytes from fluids, achieving high recovery and clean extracts. For more information, check out the links in the description. If you enjoyed this episode as much as I did, be sure to like and subscribe to check out all of our latest releases.